All right, hey y'all, it's Miss Summers. Today is September 23rd. We are starting our third unit this year, which is Big Geosphere, Big Lithosphere, whatever you want to call it. And we are starting today by looking at continental drift. So we want to look at how do we know that the continents have moved? How do we know that? All right, so I sent y'all an email yesterday or this morning sometime. I sent you an email that had some pictures in it, some pictures that go along with these notes. I think these diagrams are really helpful, and I wanted you to have them. Normally, I would provide them in class, but since y'all are virtual, that's the best we can do. Okay, so have those handy, either printed out or to the side in another window so that you can go back and refer to them. All right, so continental drift is this idea that was proposed by this fellow named Alfred Wegener in 1912. So Wegener actually, a little backstory on him, he started off his scientific career not as a geologist, but he actually was a climatologist and a meteorologist, so he studied weather. But he got interested in this idea that continents moved around while he was looking through some old maps and books and things. And he was like, this is interesting. All right. So he basically says that 250 million years ago, there was a supercontinent called Pangaea. And Pangaea looks like this. All right, so all of the modern continents, so this is like Europe and Asia, North America, South America, Africa, the Arabian Peninsula, Australia, India. India is by itself. And Antarctica. They were all linked together. Okay, it was one great big landmass. And you probably already know that from like third grade or whatever. It's probably when you first learned this, that there was Pangaea. All right. Pangaea then broke apart into two other supercontinents called Laurasia and Gondwana land. I'm not going to ask you that. And that took about 50 million years. And then as time progressed, the continents began to spread apart further and further until they ended up where they are today. All right? So geologists were like, Alfred, this is crazy. You have to prove this. And he was like, okie dokie. He spent his whole adult life finding these 4 forms of evidence for the existence of Pangaea. All right, so this is how Alfred Wegener knew that the continents were at one point together. All right, his first piece of evidence was the one that really got him interested in this, is the puzzle piece evidence. Now, we all know that puzzles work. You take 2 pieces, and one side is opposite the other side, and they fit together. And he was like, yo, the continents look like they're puzzle pieces, particularly along the coast of South America and Africa. These 2 places, especially like these little brown areas right here, that's where the continental shelves match down in the ocean. All right, so it's like, wow, those look like they go together. And even like this little part of Europe and North America, the eastern coast of North America and West Africa, they all look like they kind of you could put them all together. All right, so that's one piece of evidence. Our second piece of evidence is the distribution of fossils. All right, so we looked at a map, and now we're going to look at living things, or the remains of living things. All right, and you have this picture. Plant and animal fossils can be found on the coastlines of different continents. And when you put the continents together in their puzzle piece way, like a puzzle, the fossils line up. All right? So this little creature, Cygnognathus, something like that. Who knows? All right, it was a land reptile. Its fossils can be found in South America and in Africa, but it can't swim. This is not a swimming critter. This little fella can't swim. All right, plants, Glossopteris. All right, fossils of Glossopteris have been found in South America and in Africa and in Antarctica. That's like really different. And in Australia. All right, they all line up. All right. This was kind of the big example that he used. It was the Mesosaurus. The Mesosaurus was a like semi-aquatic reptile that would not have been able to swim across an ocean. Because if it could swim across an ocean, then it should be everywhere. All right. So people who were not Alfred Wegener were like, well, maybe the Mesosaurus used a land bridge. And there was a land bridge, and they walked across it. And Wegener was like, okay, fair enough. You know, land bridges are a thing. Like that's how it's hypothesized that humans got from Asia to North America. But if there was a land bridge, there would be remnants of it. There would be like evidence that it existed at some point. And there's not. There's no land bridge that would have connected South America and Africa. The only explanation is that at one point they were together. All right? So we have a map. We have the puzzle pieces. They fit together. The fossils line up. This is Mesosaurus, by the way. BT dubs. All right? But he's like, but wait, there's more. Rock types and structure. So this is where he appeals to the geologist. Mountain ranges each have their own unique characteristics, okay? They're made out of certain rocks. They're a certain age. They have different features that you can tell that something happened to them at some point in their history. And these mountain ranges appear to end at one continent's edge and reappear on another. So the Appalachian Mountains, which are just to the west of us, all right, they start down here in Georgia and they go all the way up through Maine and the very eastern part of Canada. And the Caledonia Mountains here in Scandinavia and in the British Isles, they are the exact same. They're the same age, the same materials, the same features. It looks like they belong together. So Wegener was like, well, if you put my puzzle pieces together, these mountain ranges line up. All right, and obviously mountains can't move across land bridges. So he was like, haha, I got you again. All right, so we had the puzzle pieces, the fossils line up, the mountains line up, but he was like, but wait, there's more. Ancient climate. So remember, he started his career as a climatologist looking at weather and climate. He found evidence that there used to be glaciers in Africa and South America. Now, Africa, particularly this part right here, is a very warm place. All right, you would not have a glacier form there ever. Even in an ice age, you can't get glaciers forming at the equator. So he was able to tell that these glaciers existed 200 million years ago and then they melted. If the continents were always here, like if Africa had always been in this location, you would never, ever, ever, ever form a glacier here. So that means during Pangaea, when all these things were together, look at where Africa is in Pangaea, it's much closer to the South Pole, towards where Antarctica is today. All right, so he has glaciers where it's too warm for there to be glaciers, but he also has coal in Antarctica, which is interesting. So coal, we're going to talk about coal a lot later on this year, so just get used to it. Coal is the remains of fossilized plants. So remember Glossopteris, that fern that he found on like every continent, like South America, Africa, Australia, and Antarctica? Okay, some of those plants had turned into coal, and that implies anywhere where you have coal, that means there used to be a forest there. The plants turned into coal. So Antarctica, obviously if you go to Antarctica today, there's no forest there because it's way too cold. So at one point in time, Antarctica was a little bit warmer. It was closer. It wasn't at the equator, but it wasn't where it was today. It was somewhere slightly warmer. All right, so he has all this really cool evidence. He's got the puzzle pieces that fit together. He's got the fossil ranges that line up, the mountain ranges that line up, and he's got the climate evidence, with the glaciers. There used to be glaciers at a place that's now at the equator, and he has coal in Antarctica, which means Antarctica had to be somewhere warmer. So, of course, all the scientists just love and adore Alfred Wegener. They're like, oh my gosh, you're a genius. You're so smart. They didn't do that. They were like, no, Wegener, you're crazy. You're so silly. All right, and the reason they did that is because in his hypothesis, he could not explain how the continents move. This was Wegener's biggest downfall. Quick story time. So Wegener, again, came up with this idea in 1912. He spent the next 30, almost 40 years trying to figure out how the continents moved. He spent his entire adult professional life trying to figure this out. And he went on expeditions. He went on these little missions to different places all around the world to try to find more evidence. And he ultimately went to Greenland, which is up in the north, really, really cold. And he ended up freezing to death on his 50th birthday trying to figure out, how do these darn continents move? And he never got the answer. So Wegener was under the impression, he was like, maybe the continents just float on water. Like we're big like sponges floating in the middle of the oceans and they just kind of move around. So he was like, maybe you could like swim under them hypothetically, which is not true. Like you definitely can't do that. But his evidence that showed Pangaea was correct. Pangaea was a thing. He just couldn't get to the how does it happen. All right, and he was a case of a scientist who was too far ahead of his time. He didn't have the right technology to figure out this part. He knew the continents moved. He was right in that aspect. He just didn't know how. So our boy Wegener, dies, unfortunately, by himself. He's kind of a joke to the whole scientific community. But over a few decades after his death, technology improves. We start to be able to look at the ocean floor a little more in detail. We get to look at where earthquakes are occurring, the magnetic field. And in 1968, the theory of plate tectonics is proposed. All right, and this brings Wegener's ideas and explains how it happens. All right, so ultimately he does get the last laugh, if you will. Okay, it just took time and it took some other people and some technology to get there. All right, we're going to talk about that on, let me look at my thingy. We're going to look at we're going to look at that on the 22nd. I just realized at the beginning of this video, I told you it was the 23rd. It's not. It's the 16th. LOL. But I'm not going to redo my whole video for that. All right, so we are going to talk about the theory of plate tectonics and how the continents move next week. Okay? So, if you have any questions, email me, put it in the comments, whatevers, and I will talk to you soon.